Thank you. So my name is Andrej, and I come from a company called Center. I'll be talking about Melon Mail, which is a secure messaging system that we have developed for Melon port. As you all know, email has become a de facto standard for our daily written communication, both for individuals and companies. And because of that, most of the people today assume that email is a safe method of communication. Safe in a sense that the information we transmit through email is not going to be accessible to anyone beside the intended recipients. And unfortunately, this is simply not the case. Well, first of all, the email content goes unencrypted by default through many intermediate servers before it reaches the final destination. So it is enough for only one of these intermediate points to be compromised in order for the entire system to be insecure. And even after it reaches the final destination, the content will remain stored in plain text on some private server, where it is going to be susceptible to all kinds of intrusions, be it from hackers or internal employees or governments. And finally, it is no longer a secret that our email often gets inspected by bots in order to serve better targeted ads. And this holds true for some of the most popular webmail services. And some would argue that this is not a privacy breach because it is only bots and not actual humans that are reading email. But my point is, if the bots can do it, why couldn't the CEO of the company that is behind it, or senior management, or the engineers that are working on training those bots? You get the idea. So all of this is not a new issue. Various groups and individuals have been raising awareness about it for a while now. And as a result, we have seen various solutions to the issue, mostly in the form of webmail encrypted services. So it's basically webmail services that use some kind of encryption to protect the data from intruders. And they're doing a good job of solving this problem to a certain extent. But I would argue that all of them still suffer from one serious drawback, and that is that they are all centralized. What does it mean? Well, if they're centralized, they have two serious problems. First of all, everything is still owned by a single company. And when I say everything, I mean both code and the data. And this code is usually not open source. So there are no actual guarantees that the system is secure. Because if no one can see the code, then it is possible for a company to sneak in the backdoor if they wanted to, or if they were forced by some authority. The second big issue is that they have a single point of failure. So although they can be considered secure, they are still fragile and cannot be considered reliable. Because if the company that is offering the service terminates for whatever reason, the data will no longer be there, and the service will no longer be available. And bear in mind that these are not some theoretical issues that only paranoid, security-minded people care about. We have seen these both scenarios play out in reality with a service called LavaBit. LavaBit was quite popular secure messaging service back in 2013. And it received a lot of attention back then because it was revealed that Edward Snowden had been using it. And as you probably know, Edward Snowden was not very popular in the United States back then. So, according to LavaBit's CEO, the United States government demanded to install surveillance equipment on their network, with which they had to comply with. This shows us how sensitive these systems are, because if they can sneak in a backdoor without anyone knowing about it, then how is it secure? And this wasn't enough because the data was still encrypted. So the next step was for government to ask them to give up their private SSL keys, which would basically allow them to read emails from all the users. And at this point, the company decided to shut down instead of to comply. And this shows us how fragile it can be if the service has a single point of failure. And I'm not criticizing LavaBit here. I think they did a pretty good job. This is basically the first time in history that a company has decided to terminate instead of to comply with government's request. And I think they did probably the best they could at the time. But I also think that today we can do better. So that's where Melon Mail comes in. Melon Mail is a fully decentralized, end-to-end encrypted, web-based, and open-source messaging system. I'll go through this one by one. By being relied on decentralized technologies such as Ethereum blockchain and IPFS peer-to-peer storage system, Melon Mail has no single point of failure. No one controls the data, no one owns anything. everything, all the logic is implemented in the front-end code, and the back-end is essentially smart contracts. So basically, the front-end code can be run from anywhere, and the smart contracts run everywhere. So once deployed, the service is practically indestructible. Obviously, it is end-to-end encrypted, meaning that the data never leaves user's browser without being encrypted first. When I say web-based, this is important because there are existing services that are doing something similar, like BitMessage, for example, but they require to download their own native client, which is too high barrier to entry, I think. And of course, it is open source by design, which means that anyone can inspect the code and make sure that it is not doing anything it is not supposed to. Also, we encourage people to do their own deployment of the service instead of relying on the existing instances deployed by others. Also, developers can integrate the service very easily with their existing websites. Okay, so I'll show you how it works by explaining it on an obvious example of Alice sending an email to Bob via Mellon mail. Okay, so here we have Alice's browser with all the front-end code running within it. There is IPFS network, and in case someone doesn't know, IPFS is basically a peer-to-peer storage system. I think someone already mentioned that before. And Ethereum blockchain, hopefully all of you know what it is. So bear in mind that there is no backend server here. This is all that's in play. So Alice writes an email to Bob. Bob has an email registered at melon-mail.eth address, which is also decentralized because it's based on the Ethereum name and service. Okay, so the first step would be to resolve this domain, actually. So the front end contacts Ethereum blockchain to resolve the domain to the mail contract. We have slightly extended standard ENS resolver here to include mail contract records in a similar way that traditional DNS has MX records. So in return, Alice will get mail contract or address of the mail contract where the Bob has registered his account. The next step is to retrieve Bob's public key from the email contract so that Alice can encrypt the email she wants to send to him. And we can see here the encrypted data that is a result of that. Next step, encrypted content goes to the IPFS. So it basically gets distributed through the IPFS nodes. So it's basically going to be everywhere, but since it's encrypted, no one is going to be able to decrypt it besides the recipient. In return, Alice will get IPFS hash, which is a unique identifier for that decrypted data. And finally, this IPFS hash is stored on the Ethereum blockchain, along with some metadata such as intended recipient, thread the mail belongs to, and so on. Okay, so I'll show you how it works in action. And yeah, I have a pre-recorded video. I wasn't brave enough to do it live. I know I paused on purpose. Okay, so as you can notice, there is no traditional authentication system here. Now Alice is creating an account, and all she needs is to sign a transaction from MetaMask. There is no password that she needs to choose because authentication is done from the existing Ethereum account. At this point, the system generates private-public key pair for Alice, public part of which is broadcast on the Ethereum network and sent as a transaction, so that people can retrieve it later when they want to send a message to Alice. And once the transaction is mined, Alice is logged in. As you can see, this is like a standard traditional webmail interface with all the basic features. She can now compose email to Bob with some, yeah, this is his email address. I've asked my developers to put in something witty, and this is what they came up with. Attachments are supported, of course, with unlimited size because IPFS essentially has no limit. And now it gets encrypted, uploaded to IPFS, and finally sent to Ethereum. Yeah, there is some basic configuration here. Users are allowed to add their own trusted IPFS nodes. This is important because IPFS still has no incentive system in place. So we have to run our own backend nodes to guarantee that content is going to keep being hosted. But this reduces decentralization to a certain extent. So we think this feature is important so that users can add their own nodes. Now we can switch to Bob's account just by changing an Ethereum account in MetaMask, and we can see that he is going to receive an email from Alice just after the transaction is mined, and there it is. It's also cool that everything is transparent here, in a sense that we can see that exact Ethereum transaction that belongs to this email transfer. I mean, obviously, all the sensitive data is hidden. We can see all the encrypted, but we can see that transaction is there. And same goes for the IPFS content. Through some IPFS gateway, you can see the encrypted data, both for sender and receiver, which they can decrypt later. And yeah, I think that will be it for demo. Okay, so the technologies we are working with here are quite new and exciting, and this means there are still many challenges and problems to overcome, both short-term and long-term. I'll name just a few of them. One of the short-term issues I already mentioned is that IPFS system has no incentive. IPFS has no incentive system in place, which means that there is no guarantee that the content is going to remain hosted. So both us, the center, and Melport are running our own background nodes too, which will keep the content indefinitely. But once IPFS implements something like Filecoin, it will be solved on a much more elegant level. Another big issue is that search on encrypted data is a very, very difficult problem. There are ways to, I mean, not actual ways, but hacks that we can use to overcome this, like downloading all the content on the front end, decrypt it all, and then perform the search. But this is not scalable nor efficient. There are some like longer-term possible solutions like homomorphic encryption, but I think this is still far from being usable in production. So yeah, we're looking forward to that. And finally, I mean, this is essentially not email. This is a messaging system because it is not directly compatible with traditional email. We could easily make it so if we wanted to. We can just run a background node that will listen for blockchain transactions and forward these emails to traditional emails like Gmail. But then it is no longer decentralized and it's no longer secure. So yeah, I mean, it was a trade-off. We could choose one or the other. It's not difficult to make them compatible. Just we wanted to make it fully secure and then be able to claim that it's fully decentralized and fully secure. So yeah, in a sense, as all messaging systems, this suffers from network effect. But hopefully more and more people will switch to these types of solutions eventually, I mean, in the long term, because we truly believe that if we are going to have some standard way of written communication, it should be more similar to this and less similar to what we have now. Okay, just to wrap up, let me say a few words about our company and our team. We are quite new, self-funded startup based in Belgrade, Serbia. We are completely focused on decentralized technologies, mostly Ethereum and IPFS. We have, although we are quite new, we have been operating for about only 2 months now. We do have a lot of experience with these technologies. I have been following Ethereum since its very inception myself, and Mate and Nikola, our lead developers, have already worked on a project similar to this. So yeah, just to show you how skilled they are, I'll say that this entire thing was implemented from scratch to what we have now in less than 2 months. And yeah, let me say special thanks to Ahmad from Melonport, who did the entire design for this, and the rest of Melonport team, who has been a real pleasure collaborating with. And yeah, that would be all for me. I think we might have a couple of minutes from questions if, yeah. But yeah, if not now, you can grab me later and ask if you want to know more details about any of this. So thank you.